Hey guys, this is Mr. C, and in this video we are going to be writing some equations of lines. And so before we get started with these problems, the first thing I need to do is refresh your memory on a few things. First thing we're going to need is the slope formula. Everybody should have that written down in their notes. The second thing we need is the slope-intercept form of a line, which usually this is the finished product that we're going to want to have. Again, you have the y and the x, independent variable, dependent variable, the slope in front of the x, and the y-intercept at the end. That's your b value. And then you have the point slope form, which is going to be kind of our middleman here, our go-between, to take our information and turn our information into an equation in slope-intercept form. This equation looks very similar to the slope equation. As a matter of fact, it's so similar that a lot of times you don't even need to memorize both of them. This one can be derived from the slope formula because all you've done is taken the x minus x1 that used to be down here, and it used to be x2 minus x1, by the way, and you've just moved it over here with the slope, and now you have what we call the point slope form. The only thing that's different is that we only have one point, and so we need a point and a slope to complete this, and we can get that from our information, as you're going to see. But the y2 and the x2 have just been turned into an x and a y. The reason why is because at the end of this, I want an equation that does have an independent variable and a dependent variable in it. So if I don't take those little two subscripts out, I'll just get a number for the slope, and that's not going to do me any good for an equation of the line. So therefore, the x and the y have to stay there at the very end so that I have a usable equation of that line to graph or do whatever I need to with it. So those three things we're going to need. And so our first example, and I've just picked a few of them out of my many. It says, write an equation of a line in slope-intercept form, very common, with the following information. I want the slope to be 2/3, and I want it to pass through the point negative 6, 1. So what I do is I take my point slope form, y minus y1 equals m times x minus x1. And I'll just let you know as a caveat, there is another way to do this that your teacher might show you with the y-intercept kind of a thing going on, and textbooks might show you this. This is my standard go-to method that works every time. So this is the one I'm going to be using every single time. All right, so my slope, 2/3, right here, I'm given. And so that 2/3 has to go here. I also have some more information. I have my x1 is negative 6. So that's going to go here. And I have my, let's see, I've got my y1 here as 1. So we're going to put a 1 right there. And if we plug all the information in, let's see what happens. We're going to get y minus 1 equals 2/3 times x minus a negative 6. All right, so let's take a look at that. Minus negative 6. The minus is in there because of the formula. You're plugging in a negative. So these two negatives are going to make a positive right there. That is the most common mistake by far for these problems, is when you get a negative number, failing to take these two negatives and turn it into a positive. The same thing could happen here too. If that was a negative, it would change that to a positive. So we just have to be careful of that. All right, so we have two steps. Step one, as soon as you get into point slope form, you're going to distribute your slope, and then you're going to move the constant over if there's a constant. So that's what we're going to do. All right, so let's distribute our slope. And let's see what happens. So the y minus 1 stays, right? Didn't do anything to that, equals 2/3 x, 2/3 x. And then you have 2/3 times 6, and we've talked about this a lot. 6 times 2 is 12, divided by 3 is 4. And so that's going to be n is positive, so plus 4. Now, the only thing left to do to simplify this is to go ahead and move your constant over, if you have one. Plus 1, plus 1. Remember that these guys cancel. And so our final answer would be y equals, all that's left over here is y, 2/3 x, and then plus 5. All right, so how do you check this to make sure you're right? You just have to make sure it has the correct slope, and it does, 2/3, 2/3. And you just have to make sure that when you plug -6 in for x, that you get 1 back. And so if this was -6, you'd have -12/3, which is 4, and -4, plus 5 would be 1, and so you do get the 1 back. So they're pretty easy to check if you need to check them. If you're taking a test, you definitely want to check these. Just a little check at the end to make sure you're right. All right, next example. We have a slope of -5, passes through 3, -4, so let's see how that works. I've got my slope, so that's my m. I've got my x1 right there, and I've got my y1. This time I'm not going to write out the whole point slope formula. I'm just going to go ahead and plug them in as I go. So y, now it's going to be -4, isn't it? So if I put minus -4. If I put y minus -4, I can do that. And maybe I probably should for this one. Equals -5, the slope, times x, and then -3, because that's x1. All right. So one thing I can do here is I can take these two negatives and turn that into a positive. Again, by far the most common mistake when people are working these out. We can go ahead and distribute if we want to over here, because that's not going to affect anything. So -5x, and then -5 times -3 is a positive 15. All right. Last step is to just go ahead and move the constant over. -4 on both sides. Additive inverses cancel out. Bring your y down. By the way, this arrow right here with this double arrow, that just means next step. It's not an equal sign. It's just pointing you towards the next step of solving the equation. Equals -5x. And then positive 15 take away 4 would be, I believe, positive 11. And then that should do it. So let's check. Slope is correct. Correct. If you plug in 3 for x, you get -15. -15 plus 11 is indeed -4. And so we know we have the correct answer. All right. Let's do one more of those. This time we've got a couple negatives here. So let's see what we've learned. So we have our slope right there. We have our x1, we have our y1. So let's just go ahead and do this as we go. Y minus -2. That would be y plus 2 equals -3/4 times x. And it's minus -6. So it's really going to turn into a plus 6 right here. All right, so what do we have now? Next step. Let's go ahead and distribute. That's what I always do first. I think that's probably what everybody does first. And let's see what happens. So this time we get y plus 2, nothing changed over there, equals -3/4 x, -3/4 x. And now we have to do 6 times -3/4. So let's do that up here. -3/4 times 6. And that's really 6/1, right? So sometimes I'll put a little scratch work in the blank part of the paper up here. Here's the thing. The 4 and the 6 both share a common factor of 2. So hopefully teachers have shown you this. You can cancel these out like that. You can take a 2 out of those. And you're going to get -3 times 3, which is -9, over 2 times 1 is 2. Now you would have gotten the same thing anyway if you would have multiplied across and then simplified. But what I did was I kind of knocked out 2 steps in one here by this little simplification part right there. So here's what I've got now, -9/2. Okay, I'm going to have to subtract 2 on both sides. Okay, so now I've run into another dilemma. These are going to cancel, but I've got y equals -3/4 x. And then I've got -9/2 take away another 2. So what is that? So sometimes what I like to do is I like to take my scratch work here and kind of box it in so I don't confuse it with my other work. We can go ahead and calculate that down here. -9/2 take away 2/1. We might want to go ahead and get a common denominator. So we already have the 2 here, where the -9 can stay. but the 2 over 1, we're going to have to multiply both those by 2. And so that's going to be minus 4 over 2. So negative 9 take away 4 is actually negative 13, isn't it? So minus 13 over 2 like that. So this is my little calculation I did here. Kind of drives students crazy when there's this little side work to be done, but that's just what you have to do. So here's what I'm looking at. I'm looking at this guy right here to see if that's correct. So I really don't want to leave it like this and just say it's correct. I want to go ahead and prove it. So what I'm going to do is on this whiteboard, I'm going to write y equals negative 3/4 x minus 13 halves. And I'm going to claim that that passes through the point negative 6, comma negative 2. All right, that's my claim. So I'm going to hang on to this for a second. I'm going to put this whiteboard here and let's go ahead and do a little calculation. So I'm going to claim that if I stick a negative 6 in here for x, right there, this whole thing is going to turn out to be negative 2. So this is going to be an exercise in fraction fluency. All right, so here we go. I'm claiming that negative 2 for y, negative 2, is equal to negative 3/4 times negative 6 minus 13 over 2. All right, so let's keep it going. Negative 2 is equal to, okay, 6 times 3 is 18, and it's going to be positive because you have 2 negatives. 18 over 4 minus, now I have 13 over 2, but I really want that to be in fourths. So I'm going to convert this fraction or rename it to 26 over 4. So now what I have is negative 2 is equal to 18 take away 26. Well, 18 take away 26, I believe, would be a negative 8. Negative 8 over 4. And then obviously negative 8 over 4 is negative 2. And so since I get the same thing on the left and the right, I know I did it correctly. And now I can go ahead and take my problem here and I can box this in. And I know I've got it right because it has the correct slope and I've proven that it goes to the desired point. And so if you're good at fractions, which hopefully you are, and if you're not, strengthen that up. And you can go ahead and check your own that way. Because you will get some with fractions as the y-intercept. It's just going to happen. All right, so let's try this one. What happens if you get 2 points? We can't just throw everything into the point slope formula now, unless you know how to do that. We're going to have to calculate the slope first. So what I'm going to do is I'm going to say x1, y1, and x2, y2. And I'm going to calculate the slope real quick. I'm going to do that over here. So the slope is going to be 6 minus 0 over 4 minus 2. Hopefully you watched my slope video. That's going to give me 6. 4 minus 2 is 2, right? And that gives me 3 for the slope. So now I know what my slope is. So when I throw this stuff into my point slope formula, since I already have this one labeled x1 and y1, I might as well just use that one for x1 and y1. You could use either one if you want to. They're both on the same line. They both have the same slope when the line goes through them. So it does not matter which order pair you use. I'm just going to use the one that's already labeled. That's just my habit. So y minus 0, and that actually makes it one step easier, equals 3 is my slope, right? 3 we calculated, x minus, and I have to pull from the same point, 2, and now I can simplify. So what happens now is when I distribute 3 right there, I'm going to get y equals, because the minus 0 goes away, 3x, and then minus 6. All right, so I don't have a slope, I have the slope to check, but if I mess that up, that's not going to help me at all if I calculate the slope wrong. So I just need to make sure that this line goes through these 2 points. So let's just do a little quick check. Let's see, 2 times 3 is 6, 6 minus 6 is 0, that's my y value. So it goes to that point. 4 times 3 is 12, 12 minus 6 is 6 again, goes through that point right there. So now I know I'm good to go and I've got the correct answer. Y is equal to 3x minus 6. So this only gets more complicated if you have to calculate a slope that's got some negative numbers in it. But that's really no big deal because we've watched the slope video, hopefully. And so let's go ahead and calculate that. Let's label our points, x1, y1, x2, y2. And believe it or not, when I'm solving these problems and I'm making them, I actually label my points like this every time because I'm prone to making mistakes. And so if I'm not careful, I will mess this up just like anybody else. So let's see what we got. -8 minus -2. -8 minus a -2 over 4 minus 1. And just remember, if you went this minus this, you can't go this minus this. You can't go backwards. You have to go this minus this, and then that minus that. All right, so -8 minus -2 is really -8 plus 2 over 4 minus 1 is 3. And so -8 plus 2 is, I believe, -6 over 3. And that is equal to -2. So that's nice. Now my work is kind of spread out over here, so I'm going to kind of gather that around and just wall it off there. So there's my slope. And again, I'm just going to use this ordered pair. It doesn't matter which one. Neither one is better than the other. So I'm just going to use this ordered pair and that slope. So y minus -2 equals -2 times x minus 1. All right, let's simplify. So I'm going to distribute my slope. And so y take away -2 is really the same thing as y plus 2, the most common mistake, equals -2x. -2 times -1 is a positive 2. Then I'm going to go ahead and subtract 2 from both sides. Cancel, and guess what? Those cancel also. So y equals -2x. All right, so let's check that one real quick. Let's see, 1 times -2 is -2. Boom, got it. 4 times -2 is -8. Got it. So now I'm very confident, 100% confident that this is the line that goes through those 2 points. Not a problem. All right, let's try this one. And let's see how this one looks. All right, now let's talk about parallel and perpendicular because you're going to get those. So this time I want to write an equation in slope-intercept form. It's got to be parallel to this line and it has to pass through this point. So when they give you these, you have to take this line right here, this equation, and you have to extract the slope from it. So what's the slope of this line? It's in slope-intercept form. So don't get all worried about the 3/2 there. No big deal. The slope is 1/2. That is your M. And it is parallel. So since it's parallel, I want the same exact slope as the given line. Here's your x1. Here's your y1. All right, so let's get to it. Y plus 1, it's a negative, equals 1/2 times x plus 10. Right? Okay, so now, as always, we're going to distribute, see what happens. Whether it's good or bad or whatever, we have to do it. And we're going to get y plus 1 equals 1/2 x. Half of 10 is 5, and it's positive, so plus 5. Nice. Last step, move your constant over if you've got one. This time we do. They cancel. And y is equal to 1/2 x. And then that would just be a plus 4 right there. And that's it. All right, let's do one more of those. This time, we're going to do parallel, but we're going to have a line that's in standard form. And again, hopefully you have watched my videos on lines in standard form like this. How do we do that? Well, the thing that I do, let me use a different color here, is remember I do A, B, and C, and I know that the slope for a line that's in standard form is negative A over B every time. So that's going to be negative A3 over B positive 4. Okay? And again, I'm parallel. since I'm parallel right there, that means I want the same slope in my line at the end. Same slope. Okay, now let's go ahead and write our information. X1, Y1. So here we go. Y minus 7 equals -3/4 times X plus 1, right? Okay, so I'm immediately going to start to get nervous because I know when I multiply these guys together, that fraction is not, the denominator is not going to cancel. But that's fine, we can do that. Y minus 7 equals, and let's go ahead and distribute that slope like this. Okay, so we're going to get -3/4 X. And then -3/4 times 1, positive, is just still -3/4. All right, now we have to add the 7 to both sides. Okay, so we're going to get Y equals -3/4 X. Okay, now what? Okay, down here, let's do a little scratch work. -3/4 plus 7/1. Common denominator is a 4, so I'm going to rename the second one. And then that's going to be, instead of 7/1, that would be 28/4, right? So what happens is 28 plus a -3 would drop me down to a 25, and it'd be positive, so plus 25/4. And then that should be it for that one right there. All right, we got a couple more. So instead of parallel, they could give you perpendicular, and they're going to give you perpendicular. So here's the deal with perpendicular. The slopes of two lines that are perpendicular have a product of -1. You're going to learn that as a theorem in geometry. And so in order to find the slope of a line that's perpendicular to another line, we need to find a number that when you multiply it by this, you get basically -1 as a product. Well, the easy way to do this is to take this slope and make the opposite reciprocal from that. And so the opposite reciprocal of -4 would be positive 1/4. If you multiply these two numbers together, you get -1. And so you can't write m is equal to anymore because m is the slope of this line. So what I like to do, and this is something that probably I'm the only one that does this, I write m with a little subscript with a perpendicular symbol equals 1/4. All right, so I've got x1, I've got y1, and then here we go. So y minus 4 equals 1/4. Biggest mistake here is people do not see this perpendicular and they just take the same slope here, and that's how they usually will mess it up, especially on the ACT. Times x minus 5, and then here we go. So we got y minus 4 equals 1/4 x. Let me show that distributing going on here. I like to do that. 1/4 x. And then 1/4 times -5 would be -5/4. All right, now we all see what's going to happen. You're going to add 4 to both sides. Those cancel. Y equals 1/4 x. And now we have to go ahead and calculate this. So we got -5/4 plus 4/1. All right, let's rename the second one because I want a common denominator of 4, right? So -5, this one stays because it already has the 4 there. So 4/1 is the same thing as 16/4, right? Yep, so 16 divided by 4 is 4. And so 16 plus a -5 would be, I believe, 11. So plus 11/4 should do it. And then you have the correct slope here as the one that you want here. And then you just have to plug in the x and the y values to see if this is a true statement, just to check your answer to see if it's right. And you really should do that when you get some spare time. So here I'm giving you a line that's in slope-intercept form. here, I'm going to give you a line now that is in standard form. And so now, I'm going to do the same thing I did before, A, B, and C. But I'm going to show you a little trick. And here's that trick. The slope of this line, M, is equal to negative A over B, right? But we don't want that. We want perpendicular to that. So the perpendicular is the opposite reciprocal. Well, the opposite reciprocal of negative A over B is going to be positive B over A. So actually, if my line's in standard form, I have an easier job, really. And so B over A would just be negative 5/6. And then that's it. That's the slope I want. All right, so let's see. We got Y. Oh, I didn't do this, did I? X1, Y1. Y minus 2 equals negative 5/6 times X plus 9. Don't forget that. And now we're going to distribute. So we distribute this guy to both of these, and we're going to see what happens here. So we're going to get Y minus 2 equals negative 5/6X. So negative 5/6X. All right, now 9 times 5 is 45 divided by 6. So plus 45 over 6. And it is negative. So actually it's plus negative 45 over 6. So we're going to say minus 45 over 6. All right, I could reduce this down a little bit, couldn't I? If I want to write everything out again, I could do that. I don't want to write everything down again. What I want to do really is I just want to add 2 to both sides, like that. And so what I'm going to do is instead of reducing this fraction down, I'm just going to go ahead and say negative 45 over 6 plus 2 over 1. Then I'm going to go ahead and rename that second one. Okay, this one's still going to be negative 45 over 6. This guy, though, is going to be, if I want that to be a 6 down here, then I got to make this a 12 up here. So now I've got to take negative 45 and take 12 away from that, and that should give me a 33. So I have Y, and let me go back here, Y equals negative 5 over 6X. And then I have, then I said 33, right? It's minus, because negative 45 is bigger, minus 33 over 6. Now, if I leave it like that, I'm kind of leaving things unsimplified because you can divide both of those by 3. And again, all of your professors are going to want to see that. A lot of teachers will have mercy on you. They'll write a little arrow to that and say simplify. I'm going to go ahead and simplify it just because it's just going to bother me if I don't. Negative 5 over 6x, and minus, if I divide both of those by 3, I would get 11 over, and that would be 2. And then what I would do is I just check my slope here, and then I plug in a negative 9 for x, and then just make sure I get a 2 for y when I'm done. All right, guys, so that is how you write equations of lines. Once you do a few of these, they're kind of all the same. Pay attention to particular things, especially when you have negatives in the points. Pay attention to the words perpendicular or parallel, because perpendicular means opposite, reciprocal. And I would highly advise people when they're first doing this to either circle or highlight that word perpendicular, or even write this down in their paper to keep them focused, because like I said, in all my years, that's in these problems, the very biggest mistake that I see is not putting the correct slope here for your, or even into here for your point slope form, and then you just wind up with something different. And then they go to check it and it doesn't work. All right, so guys, this is writing equations of lines. Hopefully it helps. Remember to like and share. Subscribe to my channel if you haven't already. Spread the word, and we will see you guys later. Bye.